All right, first we're going to start with our learning objective. What is it we're trying to learn? Well, take out your learning objectives here. Get this recorded. It's Monday today. We're going to relate the exothermic and endothermic chemical reactions. What? Okay, don't worry. Don't stress. We're going to learn about them today. What are exothermic? What are endothermic? We're going to relate those two chemical reactions to the temperature and energy changes that are happening in each. So I'll be able to describe to you by the end of the day, I'll describe to you a temperature change that happens during a chemical reaction, and you'll be able to say, oh, that's an exothermic, here's what's happening there. Or I'll say a different type of temperature change, and you'll say, oh, that's an endothermic, here's what's happening there. You just saw some stuff, right? You saw those fireworks? That was releasing a tremendous amount of energy, right? Just a preview. That's going to be an exothermic reaction. What about that British scientist dude, the science teacher? He was mixing and making that chemical reaction happen inside of the little beaker. Was there a temperature change there? Yeah, it got way cold, right? It froze the water on the bottom of that beaker. That's an endothermic reaction. We're going to learn how does that actually happen, what's going on there today. Make sure you've got the note sheet. It's endothermic and exothermic notes. If you don't have that yet, get up, grab one from the front desk there, and pause the video obviously while you're gone, and we're going to jump into the notes with our first guiding question of the day, which is why do some chemical reactions get hot while some get cold? Like, what's going on there? Well, let's get into it, as I said. First, though, we got to back up. We got to back up. We got to think about what are ionic bonds, what are covalent bonds, what are bonds, anyways. Okay, so my first job is really go think about that. What is an ionic bond? Have a solid sentence in your head. If you don't have it in your head right now, go find it in your notes. Pause the video while you do that. Get what is an ionic bond? Okay, I trust that you've gone and found that. If you haven't, you're really selling yourself short. You go through that process, okay? Hey, what is an ionic bond? Here's my version. Well, it's when atoms give up or take in electrons to get a full shell. So some atom is going to totally give away an electron. Another atom is going to totally take that electron on so that they both can have full valence shells. Remember, we're talking about that outside valence shell in chemistry. That's going to make them become ions. Somebody now has an extra electron from their neutral state. So if you get an extra electron, you've got one more negative charge than you had before, so you're a negative ion. If you got rid of an electron, that's going to make you a positive charge because you have one fewer electrons. They're then going to stick together, right? Because they're going to have that charge, and we've got an electromagnetic attraction. They're like little magnets that sticks them together. That's an okay way to bond. Lots of chemicals do that. It's an ionic bond. Let's take a look at a different type, though. We've got this other thing called covalent bonds. Again, remind yourself in your head. Take a look back at your notes. Make sure you've got it right before I show you. Go through that process now. Okay, so you've paused the video. Now I'm going to show you what I think a covalent bond is. That's when atoms share valence electrons. Okay, there's a sharing. Both atoms are going to be holding on to a pair of electrons. Remember, they're always going to share in pair. One atom will give one electron, the other will give one, and they'll share that pair together in order to get a full valence shell. As I said, the atoms are going to share electrons in pairs, and each pair of electrons is considered one covalent bond. All right, let's move on to some pre-lab notes here. Pre-lab to Friday's lab. Holy cow, you got a lab on Wednesday, and then Friday you're going to have a lab that utilizes these notes and relies on these notes. What is it that happens to atoms during a chemical reaction here? We got to think about that. Okay, first step, before a chemical reaction can even happen, or as it's happening, really it's the first step, bonds between atoms break. The atoms that were already there were arranged in some sort of situation. They had some kind of compound arrangement going on, we imagine. So we've got to break any bonds that exist. That's gonna take energy. Remember, energy. What is the definition of energy? Oh yeah, it's the ability to cause change or do work. Cause change. Break atoms apart from each other. Break bonds. That's a kind of change. Totally. It's doing work. So we put some energy in to break the bonds that already exist. That's the first step that has to happen in a chemical reaction. Make sure you get those notes down. All right. How about our next step? Well, the next step is then the atoms are going to rearrange and form new bonds. Remember, that's our definition of a chemical reaction. Atoms break apart from each other, rearrange, and form new bonds to make some sort of new compound that wasn't there before the chemical reaction. This rearranging, and especially, I should really just say, the formation of these new bonds, it's going to give off energy. There's energy associated in that. They're going to be more stable in this new bond form than they were when they were broken all apart from each other, while they were like loosey-goosey before they'd snapped into the new bonds. This part's always going to give off some energy. All right, so just to review this part here at the start, when bonds break between atoms to get everything started, to free those atoms up to rearrange, that's going to take energy. And then the atoms rearrange and form new bonds. The formation of new bonds will always give off some energy because now they're stable again. So they release this energy into their environment. Okay, so this is step one to understanding endothermic versus exothermic, understanding that these atoms, it takes energy to break the bonds and it gives off energy when they form new bonds. Now we got to go think about what is heat, what is temperature anyways. Oh, okay, go back to your notes, remind yourself, what is heat? Heat is something about, I forget, let's take a look. What is heat? It's random vibration of particles. Remember, all particles, all atoms are vibrating around. Heat is that random vibration. Okay, so what is temperature then? Well, temperature it's a measurement of the average speed of those molecules' vibration. What we're doing when we measure something's temperature is we're really measuring how quickly those atoms are vibrating. And we're averaging out all the different molecules that are vibrating, all the different particles that are vibrating in that substance. Well, that's fine, but then what does it mean for something to be cold? Anyways. Well, I guess, okay, so if heat is random vibration of particles and we're vibrating very, very quickly, then I guess we'd be hot. And if we're vibrating more slowly, now I'm not saying stopped, what I'm saying is vibrating more slowly, then that thing is cold. And on the flip side, what does it mean for something to be hot, or I should really say hotter, is that the molecules here in something that's hotter will be vibrating more quickly. So we got slow vibration for molecules that are cold. We have faster vibration for molecules that are hot. Okay, all right. Okay. I think I'm with me. I think we're starting to see something here, but what does that have to do with reactions and energy and this exothermic endothermic thing? Well, let's take a look at some more detail here. Why do some reactions release energy anyways? Well, if it took energy to break bonds and gave off energy to form new bonds, I wonder, oh, okay. So it's like this. Some reactions will take a little bit of energy to break the first bonds. Here's a reaction where we've got hydrogen gas, H2, and oxygen gas, and we're going to provide a little bit of a spark to get the atoms to break apart from each other, and then they're going to snap back together into water molecules here, H2O molecules. It's going to take some energy to break these H2s and O2s apart, but then when they snap back together, it's going to give us a lot more energy. This is energy that's in the system here. You see heat and light, chemical energy. It's going to take a bunch of energy to get them broken apart, and then the amount of chemical energy that's in those chemicals drops down because it releases energy into the environment. Okay, let's get rid of that and take a look. Okay, so it took energy to break the bonds to start the reaction, but there was more energy released by the formation of the new bonds. Okay, if we release energy, it's going to take energy to break those bonds to start, but there was more energy released by the formation of the new bonds. The term for this is exothermic. Exo, like an exoskeleton. Oh yeah, exoskeletons on the outside, right? Exothermic gives energy off. That's how I actually remember it. I always think exoskeleton is on the outside. Exothermic gives energy off into the outside, into its environment. Oh, if we break this term down here, exo is like outside. Thermic, that's our root word for temperature and for heat, right? Thermometers measure temperature, measure heat. Exotherm, so giving off on the outside heat. Exothermic gives off heat. Okay, let's look at the flip side here. Why do some reactions take in energy? Well, in these ones, we have more energy going into breaking the bonds at the start than was released by the formation of the new bonds at the end. Here's an example of that. We've got chemical A and chemical B. It doesn't matter which ones they are. But we start the reaction by putting in a ton of energy. This is our energy, the amount of energy that's in the system here versus the time, the progression of the reaction on the x-axis. So we start with chemical A, chemical B here, and we're going to add in a ton of energy. It's like we're climbing up this hill with energy, putting energy in. This is where, at this point, the chemicals have broken apart from each other. They're ready to form their new bond, and then they snap back into chemical C, this new thing. But that gave off, when you go down this little energy hill, you give off energy into the environment. It only gave off a little bit. It took a ton to get it going. So overall, when we look at this reaction from the outside, we see that we had to put a ton of heat in. So more energy went into breaking those bonds at the start and getting everything started than was released by the formation of the new bonds. We're going to call this reaction endothermic. Endo means going into and inside. So endothermic reactions take heat into them. They're sucking energy in, which makes them feel cold. The molecules slow down. Because remember, what does it mean to feel colder? Oh, where was my slide? What does it mean to feel colder? The molecules are moving more slowly. If they're moving more slowly, they have less vibration, so they have less energy. So here, the energy that was in the temperature around in the room is actually going in to making these molecules climb this hill and allowing them to climb the hill. And so it feels cold. They're sucking all this heat energy in, and they're storing that heat energy in these new bonds. And we don't feel it anymore. It's no longer heat energy. It's not random molecular vibrations. It's now stored inside those bonds. We haven't destroyed it. It's just stored in those bonds, and it's no longer there as heat. They're endothermic. Okay, if it took more energy to go into breaking the bonds than we actually get at the end from the formation of new bonds, that's endothermic. Okay, very interesting. That is actually the end of today's notes section. It's pretty quick. What I'd like you to do is double check, make sure your notes are looking solid. If you want to refresh and go back and watch any of this video, you absolutely can. Now there's going to be several questions here on this lesson, which is in the form of a Moodle quiz, to answer, to double check your knowledge and to practice using your knowledge. Once you've done that, you've got several learning opportunities to choose from, depending on what your interests are and what your needs are, and then your QR code at the end of the day. Otherwise, I look forward to seeing you all Wednesday. Shoot me emails if you have questions as we go. Have a good day.